Okay, so let's pull this up. So I will post the solutions to this. However, I will start going over this. Okay. Start with multiple choice, work our way up. Okay. We'll see how we do. Okay. And if you guys have any questions, just let me know. Okay. All right, so question 1 says the diagram below represents two masses before and after they collide. Before the collision, mass A is moving to the right with the speed of v, and mass B is at rest. Upon collision, the two masses stick together. Which expression represents the speed v of the masses after the collision? Okay, well, after the collision, since they stick together, let's see, we're going to have mass of A times its initial velocity plus mass of B and its initial velocity is 0. After they stick together, you have mass of A plus mass of B times their final velocity. Okay. So out of these options, let's see. Wow, my printer did not print that very well. So if you can think about it, if you solve for velocity final, we have to divide that over plus MB, then M. Okay, so that's how you, oh, let me zoom in. Okay, so the initial velocity, mass times its initial velocity plus mass of object B, which its initial velocity was 0. That has to equal the two objects stuck together times velocity final. Well, since this had a velocity of 0, I'm gonna get rid of it. Okay. So since I'm solving for velocity final, you divide this over to the other side. So mass A times its velocity divided by the mass A plus mass B, and that will give me my velocity. So that is indeed A. Does that make sense for the first one? Since you're solving for VF. Okay. Second question. A system of particles is known to have a total kinetic energy of 0. What can you say about the total momentum? All right, so if you have 0 kinetic energy, you're not moving. So if you're not moving, and our momentum equation is P equals mv, well, momentum is 0. Momentum of the system is 0. Okay. Three. A net force of 200 newtons acts on a 100 kilogram boulder, and a force of the same magnitude acts on a 130 gram pebble for the same amount of time. How does the rate of change of the boulder's momentum compare to the rate of change on the pebble's momentum? All right. So if we look at the change in momentum, so force times time, well, the force and time is actually the same, right? So the amount of force is the same for the same amount of time. So how does it affect the rate of momentum? The momentum's the exact same. If it's the same force in the same time, the momentum's the same. Okay. Next one. Student drops 2 eggs of equal mass simultaneously from the same height. Egg A lands on tile floor and breaks. Egg B lands intact without bouncing on a foam pad lying on the floor. Compare the magnitude of the impulse on egg A as it lands, the magnitude of the impulse on B as it egg B as it lands is, okay, so if we look, impulse is equal to force times time, but it's also equal to the change in momentum. Okay, so the change in momentum is mass and velocity initial. Okay, and if we look at that, change in momentum, the final velocity and the initial velocity are the exact same. Right? The initial velocity and the final velocity are the same. Right? So this, I couldn't find C for a minute. This would be C. It'd be the same. Now, if we looked at this equation, if we looked at the force and time, on the foam pad, the time would increase, so the force would decrease for egg B. Just a different way to look at it. Number 5, let's see. A car of mass m is moving with momentum p. How would you represent its kinetic energy in terms of these two quantities? Okay, so we know our momentum equation is P equals mv. So what we can do is solve for, like, rearrange this to solve for velocity. So velocity is equal to P over m. Does that make sense? Okay. Then our kinetic energy equation is, Haley? That's what we're talking about. Okay. So instead of velocity, we can plug in P and m right there. Okay. So what you have is 1/2 m P over m squared. Okay. So just to keep rearranging it, 1/2 m P squared over m squared, or if you reduce it all the way, 1/2 of P squared over m. Okay. So that's how you would find momentum and mass in terms of kinetic energy. And that would be answer.
I think it's B, but there's no slash. Oh, yeah.
Oh, that's right. I was like, I did it wrong. Okay, so that would be number 6. Okay. A spring is compressed between 2 blocks with unequal masses, mass 1 and mass 2, held together by a string as shown above. The objects are initially at rest on a horizontal surface with no friction. The spring is then cut. What is true of the 2-object system after the spring is cut? Okay, so as we know, it said they're initially at rest. Okay, so my momentum initial has to equal my momentum final. Okay, right? So if they both started with 0 momentum, what must their final momentum be? 0. So that is, let's see, the net final momentum of the two objects is 0. That's the only thing we can say about that. How are we feeling so far? Better. So far so good?
You're recording this, right?
Absolutely.
Okay.
Oh yeah, I forgot about this. So flip it upside down. All right. So number 7 says, oh, it kind of looks blue on my computer screen right now. Oh, it went away. An object with a mass of 2 kilograms is accelerated from rest. The above graph shows the magnitude of the net force as a function of time. At time 4, the object's velocity is closest to which of the following? Okay. So remember, impulse is the area under the slope. Okay, so at 4 seconds, how can I find that area? One half base times height. Okay, so 1/2. The base is 4. The height is 2. So what's my impulse? It's 4. Very good. So my impulse is 4. Okay. Now it's asking what is the velocity. So we know impulse is equal to the change in momentum. So mass, final velocity minus mass, initial velocity. Okay. So 4 is equal to its mass, which is 2, the final velocity, which we don't know, minus mass of 2. What's its initial velocity? 0. Love zeros. And that's how you would set up this problem. Okay, so the final answer for number 7 is A.
Couldn't we get that just from looking at the graph though, because it says like 2 where it means that 4
That's not a response.
That's
sounds nice.
it. Probably won't work like that every single time
Boom.
because your force won't always be the same as your final velocity. Bless you. Okay, that's all the multiple choice. All right, some open-ended problems. You guys want me to keep going?
Yeah.
A hockey puck has a mass of 0.115 kilograms and strikes a pole of the net at 37 meters per second in the x direction. Okay? Bounces off in the opposite direction at negative 25 meters per second in the x direction, plus 5 meters per second in the y.
Oh. This didn't make any sense to me.
Okay.
Like, I got straight up.
A says, what is the impulse? Okay, so we have 2 things we have to do. We have to solve for the x, we have to solve for the y. Okay, so let's do A first. Okay, let's do impulse in the x direction. Okay. So remember, mass final velocity minus mass initial velocity. Okay. So mass is 0.115. So 0.115 times its final velocity in the x direction, which is negative 25, minus 0.115 times its initial velocity in the x, which was 37. I guess I don't have to write that small. I'm writing really small. And same thing with my impulse in the y direction. Okay, same exact equation. 0.115 In the y direction, if you guys, the final is +5. However, what's my initial in the y direction? 0. Love my zeros. Does that make sense how to set that up? That's the key right there. Okay? Mass final velocity minus mass initial velocity. Okay? So in the x direction, I got somewhere around negative 9.61. In the y direction, I got somewhere around 0.775. So what you have to do, so let's think. I have 9.61. That goes up at 0.775. Okay. You got to find your hypotenuse and angle. X, Y's are a little tricky. Okay. So a squared plus b squared equals c squared. The hypotenuse I got to be 9.64. All right, kilograms meters per second squared, or meters per second, kilogram meter per second. Okay. To find the angle, use inverse tangent. Right, inverse tangent of opposite over adjacent, 61. What do you guys get for that?
45.
So remember, that's 45. So do we want to say north of west, or you can say put the total? I'm gonna say, you said 45.
Yeah.
I'm gonna say 45 degrees north of west is what I'm gonna say. $45 north of west. Or if you put,
I got like 4 degrees.
I was supposed to say that doesn't make sense.
Am I dumb?
Yeah.
I might have been dumb.
I think you just might have put the decimal place in the wrong
It
place.
is very
Yeah.
possible.
what'd you get? 4?
It's like 4.5.
All right, 4.5 degrees north of west.
That's the answer to A.
That's the answer to A. Okay, so B says if the collision takes 0.005 seconds, what is the force acted on the puck? Well, this one's pretty straightforward because impulse is equal to force times time. Okay, so I just solved for my impulse, and I have my time as 0.005. You should be able to calculate for the force. Okay, so take that number divided by 0.005, and what did I get? I got, with 1 sig fig, I got 2,000 newtons.
That is a long problem.
It's a long problem. See, that's why our test isn't going to have that many problems. It's only going to have like 4 of these.
Right.
That's yeah. But if you mess up on step 1, you're already screwed over for the rest.
That happens in a lot of these.
Yeah.
Yeah. Okay. Let's see. Next one. Oh man, a 8 kilogram block is hanging on a string when a 0.1 kilogram bullet is shot into it, and it gets stuck inside it from below. Oh, it gets shot from below. If the bullet in the block rises to the height of 1.6 meters, what velocity did the bullet enter the block? Okay. What velocity? All right. This one's a little tricky. Okay. Here we go. You guys ready? So when the bullet hits the block. All right. I don't feel like writing all this out. Is there elastic potential energy? No. Okay. I was like, oh. Is there potential energy in the initial when the block is moving, just gets shot moving up? No. Is there kinetic energy? Okay, I like kinetic energy. So we're going to have kinetic energy initial is equal to, all right, at its highest peak, when the bullet hits the block moves up, right there. Does it have kinetic energy? Does it have elastic potential energy? Is there any work non-conserved? No. So the only thing at the very highest point is
Potential.
so potential energy, and that's our final. So when looking at this, our kinetic energy is 1/2 the mass. So if you look at the mass of the block is 8. The mass of the bullet is 0.01. So 1/2 mass velocity squared, and that's what I'm solving for. Potential energy equation. What's that? MGH. Okay, so mass is 8 plus the 0.01 times gravity, 9.8, times the height. The height is 1.6.
Bro, that makes a lot of sense.
Okay. Who can that be? Hello. Hello. Thank you, sir.
You're welcome.
Oh. Did you hear that they're getting rid of Mr. Potato Head?
Yeah.
I told you this.
Yeah.
I'm really bummed by it, honestly.
Just hours. We're not getting rid of Mr. Potato Head. They're just changing the brand name.
It's gonna be Potato Head, but Mrs. Potato
Yeah,
Head.
but they're keeping Mrs. Potato Head.
That's
No, it was the brand name was originally Mr. Potato Head. They're just changing it to Potato Head. There's
Alright.
still Mr. Potato Head. There's still Mrs. Potato Head.
No, there's not.
No, there's not.
Yes, there is. Trust me. We looked it up.
Like five.
Mr. Bowers.
Yeah.
How long is it?
10 minutes, you can take your stuff. All right, so what do we get for velocity here?
Like 5.6.
Yeah. Okay, so we got
Did
about
your math right. High five.
5.6. Now, this was the velocity when it hit. What velocity? So this is the velocity the block has, but now what we have to do from this is what velocity did the bullet? No, it's not hard.
See, I would not think this through, like on the test.
I would just think that was the answer.
Honestly.
How do I know that's not the answer?
Because you know a bullet goes a lot faster than 5 meters per second.
If it's really big.
Oh my.
Do you not remember how, like that one question where people were going really, like a guy outran a bullet? A guy outran a bullet.
Yeah, I
So
just
if
accept.
you look at our momentum, okay, you look at our momentum, all right, my initial momentum of my bullet times its velocity plus the momentum of my block. Well, it has a mass of that. What's the velocity of the block? 0 at first. All right. The final velocity of 0.1 times the final velocity, which we said was. Or no. They stick together. They stick together. So let's combine our masses. 8.01 times 5.6. You can't see that, but there we go. So my initial, which that's 0, that's beautiful. So you multiply those two, divide by 0.01.
You guys thought that was fast? 450
Yeah. So
meters per second?
1 sig fig is going to be 5,000.
I got 4,000.
5,000 meters per second.
You got 4,000?
Yeah, because I got 4,400.
I want to get 500.
It might have been just how you rounded earlier in the problem.
I thought physics was supposed to be about reality.
11,000. You said the bullet is gonna go too slow at 5, so they're gonna go to 5,000.
Did I not show you guys that
Let's see
video
how
of
many-
the electromagnetic railgun?
That doesn't even shoot it that fast.
It's not
That's
that
not a
fast.
bullet.
You never know.
You never, yeah, maybe in like
It's
200
re-entry
years.
speed.
I don't.
All right.
I feel like half the
You can shoot it
cops
out of the
are
atmosphere.
All right. We probably have.
Shoot it and then you hit yourself. We'll just go all
We'll
the
probably
way.
have to call that quits for now.
Alright.
goes 1,800 miles per hour. Is that from like a battleship or is that from like?
So what I am going to do, I will post the answers to Google Classroom. During my plan, I will try to get this done. I'll actually probably go at a lot quicker pace.
Thank you.
So if you need to pause the video at any point, you have to do that.
That's pretty catchy.
So I should be able to get, hopefully I'll try to get this done during my plan, so I'll get it in by lunch. Speaking, what was your question?
On number one,
Number
impulse in the y direction. I'm not sure how you got that.
So impossible y. So the final, my final told me my y was 5. So that's time for the final velocity. Minus impulse in the x, so minus impulse in the y. I'm not giving a y over here, so I can assume
I didn't
it's
say I was gonna make it awkward, I just said I'm gonna make sure Brandy said take your word.
All right.
Oh, really? Yeah. What was that?
She's always nice.
Yep.
I'm so hungry, dude.
The brand name was Mr. Potato Head, and they.
Every time I go into my school class, my face is always on one of my camera.
It's so awkward.
I did it one time.
She said,
Is that you?
yeah, that's.
Was it not done?
She didn't say what, I think you're like a senior year or whatever. I'm really trying to I was not gonna put it. That's just cute.
And then, what's the other one? Yeah, look up.
You
Yeah, and then, just make sure that.
Yeah.
That was right? Yeah.
I was at first, I was like, what is going on? You're fighting against the school.
Have a good day, guys.
Oh, perfect.
Have a good day, Mr. Bowers.
You too, I appreciate it.
What are you guys, what are you two girls on?
Jack, Clark, can you come to the receptionist desk?
Okay, so here is part 2